Hello everyone, welcome to my your programming club. Today we will be solving another daily lead code problem, and the problem's name is maximum score words formed by letters. So you will be given couple of things. First of all, you will be given a words array in which there will be some words, and then you will be given a letters array. These are the letters that are available to you, and there might be some duplicate letters in this letters array. I mean the words that are available to you. There might be more than one word available to one character available to you for the same character. A is available two times, C is available once, and D is available thrice here. So on, and then there will be a third array score, which will denote the score of the letters. For example, the zeroth index will denote the score of a. If it means that if we decide to use a in to make a word, then how much that will increase our score. Okay, and then the p will be represented by the first index and so on in the scores array. So this is what the score array will represent, and then what you have to return is you have to return the maximum score possible that you can achieve by using any valid set of words. Okay, so you can form as much as words as you can with the given letters, and then you have to tell what is the maximum score you can achieve. Okay, so each word should be able to be formed by each set of words should be able to be formed by these letters only. You are not allowed to use any other letters, and the frequency constraint is also there. So you can use A only twice, D only thrice, C only once, G only once, and then these O only couple of times. Okay, so these are the constraints, and then you have to tell what is the maximum score you can achieve. So let's have a quick look at the constraints of the problem or the input size before thinking of an approach. The length of the words is of order 14. The words uh, that we will be given to you in the words array, and each word is of maximum length 15. Okay, and length of the letters array that will be given to you will be of maximum size 100, it is mentioned. Okay, so and then it is mentioned that each letter will be of single length. I mean you will be given basically characters, lower English letters, and scores length. The score length of the scores array is fixed. It is of 26 size, while 0th index representing A and 25th index representing Z. So that is there, and then the scores array will be having scores from 0 to 10. Okay, so if you will be getting if you are wanting to get the maximum score, that will also be within the bounds of 32-bit integer, so you need not to take any long or something. So that is already taken care of by these small constraints, and words and letters consist of only lower English letters, lowercase English letters. Okay, so these are the constraints. So the thing here to be noted is the length of the words array is not that large that we cannot try out all the possible subset of words that we can try to form with the given letters. So keeping this in mind, uh, if let's say a words array is given to you, Let's open the board first. Let's say a words array is given to you as anything. Let's say this is the X word, Y word, Z word. Okay, and let's say you want to form a subset of words. What you Let's say you are able to form X and Z. Okay, from the given letters array. Okay, from the given set of letters. Given set of letters. Okay, so I mean, if you want to try out all the possible subsets of this words array, how many of those will be there? Each word will be having a chance either to be included in the current subset or to be excluded in the from the current subset. Okay, it can be included or excluded. It can be included or excluded in the current subset, and then you will form the current subset. Okay, so we basically are having two choices, either to include the current word into the current subset or exclude it. Two binary choices, you can say. So 2 into 2 into 2, and this thing will continue. How many number of times? Let's say the size of the given words array is, let's say, n. Okay, so it will continue till n number of times, so which comes out to be 2 raised to power n. And maximum size, as it was mentioned in the constants, is 14. 2 raised to power 14. Okay, so that many number of subsets will be there. Okay, and if you also want to form the subset, there is a technique that I will be describing you shortly, which is bit masking. Firstly, let me describe that technique, and then we will try to understand why using this technique will not get us any TLE or something, and our solution is, you know uh, will be getting accepted. So what we will be doing is, firstly let's mark the indices of this array. Let's say 0, 1, and then 2. Okay, and then you know that in a 32-bit integer there are 32 bits, starting from the least significant bit, 0th bit, to the very last bit. Okay, so these are 32 bits, so these are 0th bit, then first bit, and so on. Okay, so 0th bit will be mapped to the 0th index, and then the first bit will be mapped to the first index, second to the second, and so on. Okay, so you are mapping the bit positions of a 32-bit integer with the indices of the given words array. Okay, so how this will gonna help us in generating all the possible subsets. So if you carefully observe how many number of bits you will be required in a 32-bit integer, you will be requiring only 3 bits, which is the 0th bit, the first bit, and the second bit. Okay, so if you take a range of numbers from 1 to 1 left shifted by, what is the size of this words array? It is 3. 3 times minus 1. Okay, so it is basically nothing but, since we are only required this much number of bits. Okay, so when you left shift 1 by 3 times, so this was the 0th bit, first bit, second bit, it will be here. Okay, so the number will be like this, and when you will subtract 1 from it, basically this bit will be turned off, and only these much number of bits will be utilized. Okay, so that's why when you will be taking numbers within this range, you will be having the possible configurations of all the possible subsets of this words array. Basically, if a particular bit is set in a, and all the numbers in between this range will be called index index marks. Okay, so for example, let's say the index marks is what should we say, 5. Okay, then what will be the binary representation of 5? It will be 0th bit, first bit, second bit, and so on, third bit. So the 0th bit will be set, and then the first bit will be unset, and the second bit, which is representing 2 raised to power 2, will be set. Okay, so this will be the configuration of bits. So you can see that the 0th index is to be included in the set, and the second index is to be included in the set. Okay, so these two should be there, x and z. Okay, so this is how bit masking will work. It will tell you which indexes you have to include in the current subset. Okay, and in order to in order for you to pick the index which, to know whether this index is to be included into the current configuration or current subset or not, what you will do, you will pick one and left shift it by index number of times that you are checking. Let's say I do not know whether to take this index or not. Okay, these are two choices, so I will left shift one by that number of index number of times. So let's say I was checking for the second index. So if you left shift one by two number of times, it will be, this is the 0th bit, this is the first bit, and this is the second bit. Okay, and what was your mask? Let's say it was 5. So 0, it will be 1, then 0, and then 1, and this 0. So 0th bit, first bit, second bit, and this is the third bit. Okay, so when you will do a AND of these two, it will not be a zero quantity, it will be something like this. Okay, so it will not be equal to 0. It means that the current index is to be included in the current subset that we are forming. Okay, that is how we will get to know. So in order to check all the indices, you have to do a linear traversal. So in this 2 raised to power 14, another factor will be added, which is into 14. Okay, so if these number of operations are less than a operation limit, basically to solve a particular program, there is generally a operation limit. Ops limit is of order 10 raised to power 8 operations. Okay, and you were requiring 2 raised to power 14 into 14 operations, order of, you can say. So if you see, these number of operations are equal to this number, 22,900, 2,29,376. Okay, so it is this number, and it is very much less than 10 raised to power 8 operations. Okay, so that's why we can say that if we try to generate all the possible subsets of the words array and try to find out what will be the score of those subsets, provided that it is possible to form those subsets from the given words only, then we can easily return the maximum score that is possible. Okay, so let's quickly have a look at the implementation, then it will be more clear to you how we will be achieving this. Okay, so let me take code here. I think code is not that much longer that it cannot be fitted into the size of the board. Let's take another slide. Okay, yeah, now it's there, and let's remove this toolbar. Okay, so this is the code. So firstly, what you will be doing is, you will be generating an array of available frequencies of word. Okay, so you cannot use a word which is not available, or a word more than the number of times it is available. For example, let's say a is available only 3 times, and you are wanting to find form a word which is having 4 a's. Okay, so you cannot do that. In order to take these kind of checks, we will be forming this frequency available. So these are nothing but the frequencies of characters available for you to make set of words. Okay, so then you will be populating this vector. Okay, so once you have populated this vector, then you will be generating a score. Okay, maximum score is initially set to 0, and then for each subset of words you will be generating how much frequency of each word you will be required. Okay, and you might ask that why we are using only 26 size, because it is sufficient enough, because we are taking relative differences of each character with a, okay, as the indices in this array. So this will be the 0th index, this will be the first index, and z will be mapped to 25th index. Okay, so in total 26 size should be sufficient. That's why. And then you will be using that mid masking concept, you know, to generate all the possible subsets from this index mask. Okay, so just like I told you here, for example, mask value is 5, then its bit representation, binary representation is this, and you have to pick only the 0th index and the second index. So x is present at the 0th index and z is present at the second index. So this will be your current subset. Okay, so that's how you will be doing it. And then you will be using another linear traversal to find out which words should you be including in the current subset. Okay, then for each of the subsets you will be filling the current subset needs, or the number of frequencies of each word that will be required, with zeros. Okay, so you are wiping the slate clean for each of the subsets that you will be forming. Okay, then you will be generating the current subset needs in terms of the frequencies of each characters that will be required. Okay, then you will be checking if the current subset needs for a certain character is more than the available frequency. In that case you will for sure know that this subset cannot be formed, and there will be a variable not possible indicating that this subset cannot be formed, which is represented by current value of index marks. In that case you will break out of this loop, and you will not include its score into the maximum score. Okay, you even will not generate its maximum score further. But if this is not the case, then you will be taking, okay, how much frequency of the current character we are requiring. Okay, then what is the score that will be, increased if we decide to use that character that many number of times. Then you will be adding it to total score. So this total score will be generated for each possible subset of words that can be generated from given words array using the letters from this array letters. Okay, so then if it is possible to form the current subset, then you will update your maximum score, and at last you will return your maximum score. So if you talk about time complexity, I think we have already discussed, but for the sake of clarity, this loop will run, let's say the size is equal to n. Okay, so let's say this is equal to n, so 2 raised to power n, and this is again a linear traversal, n number of times into n, and then each word is having maximum length of it is mentioned here basically 15. Okay, so if you want you can include 15 also. Okay, and yeah, that's basically it. Then this is irrelevant because it's of only size 26. So this will be the overall time complexity thing that will be there. And if you include this factor also, I think it will still be within the bounds. So if we include it also, then you can see it is still within the bounds. I mean, it is not getting close to 10 raised to power 8. Okay, so in case the word is of maximum length, that can there be, so it will still less than 10 raised to power 8 number of operations, so your solution will be getting accepted. And as far as space complexity is being concerned, you will see that we are not using any extra space other than these 26 size arrays. I mean, we are using couple of them. Firstly, it is there, and then this. So space complexity wise, you can say order of 26 maybe, or if you are taking it as a constant, then you can say constant extra space. Okay, and this assign function will only be running 26 number of times, so it is also pretty much constant. So this is the time complexity in general. So this 15, you can say the size of maximum size of words or max size word. Okay, in the given words array. So this is the time complexity and space complexity. And if you are still having any doubts or any queries, then you may ask them in the comment section. I hope this solution walkthrough and this video added some value to your journey of owning your DSS skills. And till then, keep practicing and keep solving problems. I will see you in the next video. Thank you for watching.